Good day to you. This is the second in our Unimetrics series, which is an abbreviation for Unimetrics. In our last episode, we left off with me having pretty much tortured an answer out of you. I hope you're comfortable with the answer that I tortured out of you, and I also promised no more torturing. It is quite a turning point to see there are two different kinds of number. So we are talking about an extension to the linear number system, and in today's very brief presentation, we're going to cover the geometry that gives us the visualization both of time and the quantum paradox itself. They're strongly related, as you'll see. Now, where we left off in the information portion, we covered a lot, but we did get to the extent of discussing the propagation of light in free space with a new definition of the photon. I hope you're comfortable with the definition of the photon as being a superpositionally coordinated particle. In the common argot today, that would be superpositionally entangled. The term entangled means that the particle in question is in two different places, but it does not think that it's in two different event states. In other words, no matter what the separation of the two aspects of the same particle is what it amounts to, but they're considered to be coordinated particles when they're created by the physicists. Then the two coordinated particles are separated. That's an illusion of linear mathematics. This separation, this linear separation in space, definitely can be proved to be spatial separation. What can also be proved is they're not being separated in their event state. So when you do this to show the two so-called entangled particles, which I taught you should be coordinated, not entangled. Entangled is a confusing word. It's actually a bad feedback for your mind to keep saying entangled. So I'm not going to say that. I'm going to use the correct word, which is, quite frankly, the word that should have been chosen. But I also gave you the reason why the term entanglement came into conventional usage. It refers to the logic system entanglement. It's variable entanglement. The particles are not entangled. The particles are coordinated, but they're coordinated in a logic system that is an extension of our ordinary linear, that is, machine logic system, true or false. In superposition, as you know, that has an extra variable. This pertains to Einstein's hidden variable theory. They're related. The solution is quite interesting and straightforward once you see it, so let me present it again as I have in the not too distant past, but it's time now for summarization. And this is certainly the right time because I promised to show you what time is. A major insight which I hope you appreciate. This is how it's done. When we examined the flight of the photon, we were able to determine by cold, strict, cruel logic, but with a Hadamard gate involved, which is quite a fairy tale sort of a gate of logic. This has to do with the Schrödinger cat problem, the superposition of state, which seems contradictory to linear logic, that the cat cannot be both asleep and awake at the same time. You notice I changed the verbs, but it's the same principle. Now, the way to visualize that, of course, must be geometric, and the easy part of the whole solution can be stated easily. You simply switch to spherical visual mode. You do have to know the number system involved, and we're leading up to that. There is a number system involved. That has to be rigorously proved, or the whole system is incomputable. That is true for the complex numbers, but there's a translation called conjugate algebra, which translates between the complex number system and linear numbers, which is necessary for computation. The same is true for spherical numbers, and this has been rigorously proved. So accepting that, as you should, because I spent a long time proving that, and you can verify that on your own, although I'll be doing so in this series, now's not the right time, because that's a rather involved proof, as you can imagine, since no one ever saw it. But the linear number system is indeed derived from a higher order number system, which, magnificently enough, I think to count as a full-fledged miracle, the composite number system, a simple two-component fractional number system, is composed exclusively of whole numbers, that is, whole linear numbers. That was proved by Max Planck. We aren't going to go into that proof, but again, well, I will cover that again in summary form. But capitalizing on these insights, we now have a bona fide spherical geometry that is in every way conformable with our linear geometry, which is exclusively used in science now, as I actually stated rather heatedly in the last presentation. Forgive me, please, I do get emotional. This is profound and must be taken as such. So without further ado, let's expand on our knowledge of the spherical geometry, which helps us to visualize the flight of the photon. Now, the photon embodies the quantum paradox because the essential nature of the quantum paradox can be stated in several ways, but one of the very first of those formulations was the wave-particle duality. This has to do with a lot of experimentation that went on in the early 20th century, showing some very strange behavior of light, where some of its behavior is interpreted as particles and can be nothing else, but then the other behavior is strictly waveform, not particle, and it can't be both, but it is. So that's the paradox. In the flight of the photon, we find the solution to every form of the quantum paradox, which is why I favor this approach to the quantum paradox, the flight of the photon. It's so profound, and I attempted to convey some of the profundity, but now is not the time to extrapolate on the profundity because that's exfoliating. We need to focus so we get the actual visualization of the quantum phenomenon, which will give us the physical geometric position of time. A very interesting concept is time, of course. It's at the top of the list, as you know. This is the answer. So, when a photon detaches from the electronic system, there's a footnote here, and I'm forced to make this interjection because this is a formal presentation. So forgive me for this is not a divergence, but it is a necessary level of detail that I have to dive down to explain something. Okay. The photon is conceived to be a particle, and I'm stating that it detaches from an electronic shell. That is the ordinary generation of light. But it is also necessary to add, and this was pointed out by one of my commentators, and I appreciate this comment, the proton is also capable of emitting light. That's extraordinarily profound, but it goes to a depth that is inappropriate right here, but I wanted to mention that light does not only come from electrons. There is a property of the proton that enables it to emit light. This actually makes sense, but nobody yet knows the reason for that. I do. So I'm very tempted to tell you that, but it would go off course for now. But hold that thought, because we're going to return to the nature of the proton in its aspect of being capable of emitting gamma rays, which is, of course, a measure of light. Gamma simply refers to its frequency, but it is light, electromagnetic radiation. So, Max Planck determined, and Einstein substantiated, that when a photon detaches, it detaches in a quantized form, and that is virtually synonymous with it being a particle. And also, we are aware that when light is recovered, either in the retina of the eye, to put it one way, or on a photographic plate, it is essentially the capturing of the photon, which emanated, in our example, our typical example, it came from a star in a galaxy. But it came a long ways on a straight line. And we would not have the linear distance to that star without the fact being obvious that that photon went at a straight line. That needs to be explained because that's impossible. So that is the nature of the quantum paradox, that when the photon detaches from its electronic system. Remember the footnote about the proton, we'll come back to that. But typically in the universe, certainly in stars, the light that comes from the stars is coming from the electron system of an atom. That's a fair statement. There's footnotes in all of this stuff, but that's a fair statement. The light we see comes from the electron system of atoms. That's true. So, when it's recovered back into an electronic system, by which I refer to the atom with its electron shells. You could say electronic. That's a little bit misleading to say electronic because it has another meaning, but I think you know protonic and electronic refer to the particles. All right, so when it's recovered, it's also a particle. So what needs to be explained is what state the photon was in between the two transition points. Just using point, and it is not the strict meaning of geometric point, although actually, since it is a quantization, you could say it has something to do with the point in space. But that's not actually the nature of emission and absorption of light. It is involved, obviously, with the wave function. That's why this is so baffling and it forms a paradox, is that it has to travel as a wave. It can't travel as a particle. As I taught you in the last presentation, actually the last two, the nature of its flight through space can be described as superpositional coordination. This is a mind stretch, but of course whatever the correct answer is to the paradox will involve a mind stretch. It's safe to say that the paradox, in order to be perceived, needs to be transformed geometrically. We can't see it when we're using linear geometry. It simply can't be seen, and I'll show you why. But it can be seen in spherical geometry. Now, the way to approach that is to realize that the packet of energy that detaches from the electronic shell has a direction. And as we discovered, that direction is easily defined according to the primary force balance system in the universe, which is centripetal and centrifugal. This is the visual, or you could say physical, manifestation of the centrifugality of energy. It is pure energy. It's pure energy that is known, and it's also quantized, and it maintains its quantized state when it's in its waveform. The only way to state that correctly, such that it can be proved, is to translate the entire mathematical presentation into its geometry, which cannot be done with linear systematology because it's a grid. What you need is a polar grid, and polar in this case means there's a center and concentric spheres. That actually forms a number space. It is the proportional number space. And so the nature of this spherical system, which takes the place of a linear grid, either 3 or 4 lines, this is a 2-line system, and both of the lines are different from the lines we were taught in school because they're spherical lines. There are 2 perpendicular lines in spherical space. One of them is the force line, and for a photon, the force line is coming out from essentially the electron from which the packet detaches, and its path is spherical out. That's centrifugal force being manifested. So it's the manifestation of centrifugal force. And light does have a pressure. So this is actually a force. Now, the photon itself is the energy, and that's somewhat baffling, because the energy is changing. It is changing its, to us, it's changing its geometrical shape because it's expanding as a sphere. That turns out to be an optical illusion, but I don't want to get into mystical sounding stuff. This has a certain mystical aspect, but it needs to be proved, and mystical things can't be proved. So let's put this into proper terminology. The photon is the manifestation of centrifugal force. That's simple enough to say. The geometry is that of an expanding sphere, but the paradox is encountered when the photon is recovered. It expands as a sphere with obviously an increasing radius. That leads to the paradox, because when the photon is recovered, that sphere simply disappears. And the only way to explain that is with an application of imaginary space, that we actually have to formulate a new dimension in order to explain what's happening. That dimension turns out to be natural. So one of the lines in spheric space is what I call the radial line. And this line is the, you could say, the spherical linear. It almost sounds like a contradiction, but you can see this is a line. For instance, gravity is measured on a straight line from the center of the Earth. That's true. But what's interesting about that is it's the same line in any direction out of the center. So anywhere on the surface of the geometric sphere, which is formed by the gravitational field, the same line is at all points on the surface. So that's the intersection of the radial line with the other line, which is the sphere, which is a closed line. So the spheric surface, for instance, of the Earth, you could think of it, certainly, we know that the Earth is spherical because of the effect of gravity, correct? It's because of the protons. Gravity is a measure of the number of protons. That's a fact. So in a way, that's already the unification theory, because we know that gravity is caused by protons. It's the integral force of the protons. So the more protons, the more they tend to collect. Of course, you know that. But it's important to state the obvious in approaches like this. So now you know what the radial line is. If the force is going towards the center, that's the force of the proton. It's centripetal force. It's on this line. It's a radial line because it's a force field. The force field surface is spherical. So that's one of the lines, is the sphere, and the radial line is perpendicular to it. Do you see it? I hope so. It's really the same. Well, one can draw analogies, but really this is kind of a new vision. You have to kind of turn on your mind to see this. But the radial line is simply either gravity, which pulls in spherically toward the center, or its centrifugal force. Now that's the manifestation of the photon. It goes out, but it's inverse in a very peculiar way to the effect of the proton, which pulls space in. But the energy when it goes out is not spatial. It's temporal. Energy is not spatial. That's the whole secret. So geometrically, what that means is the energy packet, this is the photon itself, looks like it's expanding spherically. And the paradox is when it arrives, it arrives as if it went on a beeline. So what is called the collapse of the wave function is simply that. When the particle is recovered, it's as if its entire presence on the sphere is reduced to that one position. That's called locality. So if you accept the definition of locality that way, and that is the correct usage of the word, although I haven't really defined it, you can see what it means. That when the photon is in space, it has no locality. It has no position. Because it's everywhere on the sphere, you could say that that is its position, but not in space. It looks like it's in space. But when it arrives, it proves that it was never in space. That's one way of saying it, and no matter how you say it, it's paradoxical, so let's go at this one more time so we solidify this, so we actually see it. As the photon goes out, it's superpositionally entangled. So even though it's everywhere on the surface of the sphere at the same time, when it's captured, it simply was always where it was. That doesn't make sense, and it seems to defy light speed. It actually does not, because light speed has been misconceived. Light speed is considered to be distance over time. Let me show you what it actually is. We can compute the time lag, and we can compute the distance lag. But when you compute them together, you get basically light speed. Now that's a very peculiar number. It's a constant. It's a ratio between space and time that's inviolable. There's a footnote to that, because light does change speed if it enters a medium. But you could say that when it has no medium at all, it travels at maximum speed. The direction it travels is out from its source, which seems to imply that it's making a sphere that would have a radius. That radius is not real. That's an imaginary radius. So really, the photon is simply what it always was, but it's in free fall through another dimension. And when it arrives, it can be proved that it traversed that distance linearly, but obviously it couldn't have just done that. So what's happening is the photon is pressurized outward by a natural property of space, which in its effect on a packet of energy is to induce its free fall to the edge. So the photon is simply falling out towards the edge of the universe. And in spherical space, that's just one direction. To us, it seems like it's going in all directions at once. That would be an expanding sphere. When we think of it that way, our only choice when the photon is recaptured is to say that the entire spheric surface collapsed, which is a violation of special relativity. That's not actually what happens, though. There's an optical illusion involved due to the nature of a free-falling packet of energy. It remains what it was. That can be proved because it's recaptured as it was. The only difference is a redshift. None of the information in the light is lost, and there is an incredible amount of information in that photon, which, when you have enough photons essentially coming from the same source, this is how we do receive light, is as a mass of photons. So they're collected, but they're still the same photons, which is strange because obviously the wave it went out as a spherical wave. It's not a beam aimed at the telescope, but it acts as if that's all it had been. Well, that is because it was traveling through space. What is hard to describe is that it was also traveling through the other space. And that is event space. We call it event space, and we give to the name, the metric to that of event space, we call that time. However, what I'm going to show you now is that time is actually part of another number. Now that will give us the actual geometry of time so that we can see it. So the force line we think of as a single line going out. Now, when it reaches our telescope, I'll just say telescope, although it could be your eye itself, the telescope gathers the photons as they arrive, but they're arriving just as they would arrive anywhere on a spherical surface. It just so happens that they're arriving on what appears to us to be a straight line from the star. The reason that that's an optical illusion is that it not only traveled through space, it was also traveling through another dimension, and that other dimension must be the line perpendicular to the force line. The force line is that ray, and technically it's called a ray, that comes out from the center. When I do this, it's centrifugal. If I do this, it's centripetal. But for the photon, it's centrifugal. So it's simply falling as a particle out. So that the question is, why does it appear to travel spherically? It's because as it's traveling on this force line, going out, the particle itself is the sphere. And that seems to be in space, but it actually is not. It's the particle that's super entangled with itself. It's super coordinated. So that it is the sphere, and that sphere is the particle. The only way to crack that paradoxical nut is to see into spherical geometry that the surface of the sphere is a thing, and it's actually a line. It's a closed line, and that closed line is the particle. So, as the particle falls through space, it looks to us as though it's falling out, which would seem to be an expanding sphere. But actually what that is the perpendicular aspect of the force line. So as the force line is generating the position, it is a wave position, which is a contradiction, but that's essentially what super entanglement is. It's a particle in the form of a wave, but that form of the wave is in temporal space. According to the Einsteinian formulation, that's not exactly right. Instead, what it is motion space. It is angular momentum space. We use the word space in the geometric sense here because it is precisely orthogonal to spatial space. When the photon is moving through space, it's moving in a straight line. You see that. But what is moving in a straight line is the perpendicular line, and that stays intact. It only seems to be expanding in space, but it's not expanding in space. It's expanding in contraspace. It's the space that's perpendicular to space, and that is a closed line called a sphere, but it's imaginary. It has to be imaginary from our point of view, and that's the mind stretch, but that actually is the imaginary space that is captured in complex space. So the imaginary component of a complex number is very well named. It is, in fact, imaginary. Now, in physical space, it's not imaginary, but we cannot see that space, and that's what baffles us. We cannot see that as the energy packet travels through its own space, which is not spatial, it's traveling, it's not changing its event characteristic. It still has the same wavelength and frequency. There is a slight loss of energy, which means that it shifts toward the red end of the spectrum, meaning it's shifting down in frequency, meaning there's a loss of energy. That stands to reason. It's certainly not going to gain energy. It's remarkable that it retains almost all of its energy. And we've not been able to discern yet if there's a limit to our ability to see into infinity, which is a very strange thing to say. The James Webb Telescope has not really made any significant progress in penetrating the mystery of the edge of infinite space. But actually, that's part and parcel of this same paradox. Now, the way to see where time is to examine the sphere. And you have to think of the sphere as not changing its radius. It's static. And so, in spatial space, it's changing position, definitely. Or the light could not reach us. It definitely traverses spatial space. But as it does so, it's not changing in event space. And that's the definition of entanglement, is that in the case of two entangled particles, they don't realize that they're separated in event space, so that when one changes, the other one changes instantaneously because they're in the same event state. So when one event changes, there's no spatiality at all. The way to see that is very interesting. Picture a circle, and this would be how we see a sphere. Like when you look at the moon, you actually see a circle, right? Correct. So, picture the photon as a circle. And the reason we're doing that is we want to parameterize the circle on two numbers. And these are going to be very interesting numbers. One of them is space. The other one is energy. So the space number is represented by the radial line, because that radial line measures the distance separation, which we can confirm once we retrieve the light, but then there's no way to explain the fact that it didn't come directly at us. It was somehow distributed and instantaneously collapsed. It did not instantaneously collapse, and here's how you can see that. Because the circle now is representing a sphere, correct? And the way we picture a circle, we use a two-line grid, correct? And those are perpendicular. And here's where this is actual physical perpendicularity. So there are two perpendicular components to the circle. Now one of them is the frequency, right? That's a number. The lowest frequency in the universe would be 2, because there's nothing less than a frequency of 2. These are whole numbers. That was proved by Max Planck. That's actually the nature of quantization, that it has to form a whole number. Through a process of normalization, you can prove that that's a whole number frequency. But here's how you see it geometrically. With a frequency of 2, picture 2 points on the circle. Now the circumference is 1. We're just going to say that. So the 2 points divide the circumference in half. That's the wavelength. If it's frequency 4, we'll go up harmonically and skip 3. 2, 4, 8, 16. If the frequency is 4, the wavelength is 1/4, right? Because there's 4 points harmonically on the circle, making 4 arc lengths. This is the relationship between frequency and wavelength. Max Planck proved that frequency times wavelength is light speed. So you're looking at a circle that represents light speed. That's exactly the definition of the photon's speed. It's traveling at the speed of light. So that speed is a 2-component number representing the circle. The 2 over 1 is the frequency, and the 1 over 2 you can see is reciprocal. So they always multiply to 1. That's why light speed is constant, because the wavelength times the frequency is always 1. That's why Max Planck said that it's light speed, is because frequency times wavelength is always light speed. Now the frequency is a temporal number. Frequency refers to time, which is measured on a closed circle. So that's the number of points. That makes the frequency. When the frequency is made, that is basically the definition of time. So it's the number of points on the circle that divide it. So what's being divided? That is the contraspace. It's dividing a non-spatial space, and that's the wavelength. So the wavelength is imaginary, or frequency is imaginary. One of them has to be imaginary, and that is physically imagined. That is, we are limited. We can't see it, but we can see it geometrically. Here's how. If you take that circle, right, and this axis is event separation, and this axis is spatial separation. Accept that for now. That's a bit of a stretch. But here's the point. When two particles are entangled, and remember the photon is simply a super entangled particle. It's entangled with itself. But when two particles are artificially created in a entangled state and separated spatially, look at the spatial separation. Think of that as the x-axis. Okay, we can see that we've separated those two particles. But did we? It can be proved, and it has been proved almost certainly by excruciatingly difficult experiments, that those two particles do not believe that they're separated in event space. So when we do this to separate the two particles, we're creating the optical illusion. Actually, these particles are only being separated in spatial space. But there's another aspect to the separation that you can't see because it's perpendicular. Now, if you rotate that so that you're separating the two particles, but on a line, you actually can't see them being separated. And so that is the part you can't see. When you separate the two particles this way, what you don't see is that there is no separation in the event space. That event space is energy space. And here's how you can prove that. If you consider that the energy component is the frequency, that is how it's stated, that frequency is equivalent to energy. Okay? Then what is the wavelength? Well, the energy is considered to be the amount, the number of crests in a sine wave. But you can see that that's actually the number of points on the circle. That is the frequency. It's a unit division of 1 to the proportion that the frequency is a unit multiple of 1. Multiple in this case being 2, 4, 8. There is no 1. 1 is equivalent to 0 as the origin in multiplicative space. This is spherical space, which is proportional space, which in mathematics today is called multiplicative space. It could also be called divisional space, but you can see that all these terms are missing the point. Pardon the pun. But it's actually proportional space. This is the proportion of space with this dimension that can't be seen in the case of the photon. So I hope that helps explain what time is. Time is the derivative of the circle to the proportion that the other derivative is wavelength. These are reciprocal and always multiply to 1, where 1 is the circle. So you see that frequency 2 on the circle already shows the wavelength. It is the progressive lessening of the distance between frequency points. One aspect of that, we can only see one of those at a time. We can't see them together because they're perpendicular. So we can only see this. What we can't see is this. And that's the nature of the flight of the photon. That when it arrives, it seems to have gone on a beeline, and the explanation for that is that it did in radial spatial space. But in the perpendicular dimension, it's the same event. And so when the photon is recovered in an electronic system, such as your photographic plate system, to get a photograph of the distant galaxy by collecting the photons, it seems like they all came on a straight line. And now you see why there's no collapse of the wave function. When they arrive, we think that they must be somewhere on that sphere. They are, but there's no event separation. And so they simply arrive as they would have anywhere else on the sphere, on a straight line, because the whole sphere is the product of that line. And any one of those lines is what we end up seeing. But you see the optical illusion. And that's why time is such a curious phenomenon. It's one of the two derivative numbers of energy. Time is a derivative of energy to the proportion that the wavelength is spatial. Then time is non-spatial. But if you say that there's an event separation, and we do when we say light years away, that is a temporal separation of years, you're seeing the perpendicularity. So space over time is space perpendicular to time. And the way that that perpendicularity comes out is in the relationship between the two spherical numbers, 1/2 and 2/1. The 2/1 will be spatial and going out making space to the proportion that the fractional number defines the event space. These are equal in the case of a photon, and that's why the photon seems to traverse space spherically but arrives on a straight line. And that explains the quantum paradox in all of its aspects, as I'll be discussing in future presentations in this Umetr series. UMETR is hardly pronounceable, but it's short for Unimetrics, which takes the place of geometrics. It's the geometry of the universe, which is spherical and has its own number system which perfectly defines the relationship between space and time in space-time. And in a future presentation, I'll show you can also consider that time-space. And by having both aspects, we will be able to compose hyperspheric space, which defines where space goes as the protons contract space. Does it go into a black hole? No. It goes into a curve on infinity inside the quantum. And that's the definition of the Boshkovich force curve, which I discovered in 2023. I hope that at least whets your appetite. I know that's a lot, and that's 40 minutes. This is Anagalactic, bringing you the formal Unimetrics series, which will run through summer solstice. I hope you're having a good time. I'm having a blast, because I'm hearing the words that I've wanted to say for 3 years, in the case of the space-time formulation for the past 2 years. But we're going to get to some magnificent new discoveries that affect our view of deep space objects. We're going to have an exact formulation of the black hole for the first time in human history that makes sense. And we're going to disambiguate the Big Bang, which is a model which needs to be reinterpreted in spherical space, and then it makes sense. It's not what anybody has thought it is. The Big Bang refers to the injection of energy which created the universe. The universe is indeed pure energy, and the manifestation of what we call matter is due to a magnificently balanced force system which Rutger discovered, and which I discovered that he discovered. So that's the pedigree for what you're about to hear. Keep looking up. We'll be right back. It just gets better and better, so stay tuned. Thank you for watching.